So here we go with chapter 7.5, starter 3. And what have we got here? Well, we've got our usual projectile motion kind of question. So a particle has been projected at 15 meters per second at 30 degrees to the horizontal. We've got to find the distance from the starting point to when it's moving in a direction of 20 degrees below the horizontal. So pause it there, have a go, and then have a look at the solution and see if you've got it right. Okay, so here we go. We know that it's going to go this kind of projectile motion shape, and at some point down here, it's going to be going at 20 degrees. Now, that's one interesting point here is, will it be above or below the height it's projected from at the point it reaches? Well, it's going to be above because it's only now got down to an angle of 20 degrees below the horizontal. And here, the original one was 30 degrees at 15 meters per second. Okay, now the usual way into this, as you know, is that the horizontal speed is constant. So since horizontal speed is unchanged, there's no acceleration in that direction, we're going to consider horizontal motion in that direction. So we'll call this speed v, and we know straight away then that 15 cos of 30 is equal to v cos of 20. So v is equal to 15 cos of 30 over cos of 20. So that's no problem at all. So now we're going to need the vertical speed, because we're going to have to find that location. So now consider the vertical motion, and its constant acceleration because it's a projectile motion. And then we've got to break these down into their components. So if we first do all the horizontal components, well, we know what that is, 15 cos 30. So the vertical component here is 15 sine of 30. And the vertical component here will be v sine 20. Taking note, and common error, this is downwards. Yeah, so this is going to be negative later. Yeah. Okay, so that's the key piece of information in the question, isn't it? So u was equal to 15 sine 30, 15 sine of 30. Sine of 30 we know is a half, so that's 7.5. V, the final speed, is minus 15 cos of 30 over cos of 20 times sine of 20. So I've substituted in for the v here, yeah? So this is v, and that's that v up there, v sine 20 in that top right-hand corner. So here we've got v sine 20, v sine 20. Hope that's clear. Okay, what else do we know? We know a is equal to minus g, and we're needing to find the distance, aren't we? So we're going to need t, aren't we, first of all, because we've got to find the total horizontal distance travelled, and for that we're going to need t. So we can state the equation for that. V is equal to u plus at. Substituting in, we've got minus 15 cos of 30 Sine over cos is tan, so tan 20 equals u, which is 7.5, minus gt. So add the gt across, 15 cos 30 tan 20 plus 7.5. That's in a bracket, remember. So t equals 15 cos 30 tan of 20 plus 7.5 all over g. Tap that in a calculator, and that's going to come out, I hope, to be around 1.25. Okay, so we've now got the time. So we now need to know, go back, read the question, find the distance. So we need to find the position at that time. So consider horizontal motion, Sx. Must it take the time, 1.25, times its horizontal speed, which was 15 cos 30. 15 cos 30 is the horizontal speed from way back here. Yeah, that's the horizontal speed. It's been that consistently, 15 cos 30. So we get it down here. Use the answer button, tap it in the calculator, and it's going to come out to be about 16.2 meters. Now we can consider the vertical motion, and we've got u is equal to 15 sine 30 from up here. Yeah, so that bit is 15 sine 30. So that's our u. Our t, we've got from just over here, 1.25, that we've used a few times now. A is still minus g, and we want s, which we're going to call sy because it's the vertical component. So s equals ut plus a half at squared plus s0, but we don't need that because it's starting from the origin and we want the distance from its starting point. So we get sy equals u, which is 15 sine of 30, and sine of 30 we should know is a half, plus a half minus g, t is 1.25. Tap that in the calculator, and that's going to come out to be 15 sine, and I've missed something in there, haven't I? Yeah, 15 sine 30 times t. I hope you got that right the first time, so that would be 1.25 sneaking in there. Okay, now we can tap that in the calculator and it comes out to be 1.71. Therefore, the distance from starting point is equal to the square root of 1.71 squared, that's the sy, and the 16.2 squared. Well, it's not going to be much bigger than 16.2, call it 16.3. But you can again check that on the calculator. But it's going to be a little bit more than 16.2 meters. Okay, hope that's okay, and good luck with the next stuff